You're welcome to this video. We want to treat the simplex method. Now, the simplex method is a way of maximizing profit or reducing cost, either cost of production or cost of transportation, as the case may be. Before we start, let us have some explanations on that. If you look at this diagram, we have a graph book here. We have a graph plotted here. Remember the topic, linear inequalities. Okay, linear inequalities. When you have a series of equations, you solve them simultaneously. And that's what we call simultaneous linear equations. Okay, now if they are represented by inequalities like this, okay, they now become linear inequalities. And you remember, you shade the part that is required if you want to represent them graphically. And that's the sense of what we have here now. Now you can solve simplex method problems, okay, if they are just two variables. You can use the graphical method. But if it's more than two variables, then you can't use the graphical method anymore. That's why I brought this picture to explain to you so that you understand the details of linear programming. Before we continue, let us understand the basic terms. Key terms in linear programming. A typical simplex method model of the maximization type is written as this. You have maximize z is equal to 3x1 plus 2x2 plus 5x3. Okay, these are variables subject to this. This is a constraint. This is a constraint. Then you have this last point is called the non-negativity constraint. That means all your variables must be greater than or equal to 0. So let us explain. So here we're talking about here is a variable. A variable is also called a decision variable. Okay, there are variables that are alphabets, there are letters that are representing your decisions. That's why we call them decision variables. Okay, they are unknowns in the problem that you are trying to find optimal values for. Okay, they represent quantities you can control or decide upon. That's a decision variable. There are two types of linear programming problem. You either have a maximization problem or a minimization problem. For a maximization problem, okay, it is a linear programming problem where the goal is to find the maximum value of the objective function. Okay, subject to the given constraints. For example, we have maximize z is equal to all this. Okay, so you maximize profits. Okay, you maximize profit. Then you minimize the cost of operation. Okay, cost of production. That's where you have a minimization problem. But there's a way of converting minimization problem to a maximization problem before solving this. We'll get to those ones in other videos. Okay, for a maximization problem, you want to maximize profit. While for a minimization problem, you want to reduce cost, either cost of production or cost of transportation or any other cost. Objective function, okay? The mathematical expression that defines what you want to optimize is called the objective function. It's either you are maximizing or you are minimizing. And that statement is what we call the objective function, as if that is the goal of your operation. To come down, this constraint. Now, what is a constraint? A constraint is a condition or it's a limitation you have given to your operation. Okay, it's a restriction or limitation on the decision variables expressed as linear inequalities or equations. For example, you have this x1 plus 2x2 less than or equal to 10. It represents a resource limitation. Okay, what you are telling us is that if we take any quantity of x1 plus twice the quantity of x2, okay, the result must be less than 10 or equal to 10. They're a basic variable. Basic variable. In the simplest method, these are variables that appear in the solution with non-zero values. At any iteration, the number of basic variables equals the number of constraints. Okay, so let me come back again. When you say basic variable, you see that by the time we'll by the time we'll be using the simplest method, a variable that is outside the area that satisfies the inequality is called a solution. Okay, can be a solution. We're coming to that at the bottom. But a basic variable is a variable that satisfies all the constraints. Okay, if we take any variable from here, okay, from this four-sided figure here that has been marked with green, any variable you take from here is called a basic variable. Okay, it's a basic variable because it satisfies all the constraints. Let's go down. Then solution. Any set of values assigned to decision variables is called a solution. So if we come here, for example, okay, if we choose any value here, x1, x2 to be any value here, is a solution. If you choose any value here, it's a solution. If you choose any value here, it's a solution. If you choose any value here, it's a solution. So a solution is any point, okay? Any point that you choose, okay, in the space that we're talking about. But the fact that if it is here, is it feasible? Is it a feasible solution? Okay? Is it an optimal solution? That's what we're going to next. Any pair of values, okay, that is represented by the decision variables is called a solution. Then non-feasible solution. Non-feasible solution, okay? If you take a solution here, okay, let's say x1 equal to 2, for example, 2, and x2 equal to, let's say, 9, okay? Let's say our x1, this is our x1 axis, this is our x2 axis, okay? If we take any value here, for example, okay, this is a solution, but it's not a feasible solution, okay? It's only a solution to this line, okay? It's not a solution to this line. This line starts from here down, okay? Everything here does not, anything to the right side of this line is not a solution to this line, okay? So a feasible solution is a solution that satisfies all the constraints. And in linear programming, the first constraint is the major constraint that general to all of them is that all the variables x1, okay, x2, up to xn is greater than or equal to 0. All of them must be greater than or equal to 0. That's why you have that here. This is the first point here. X greater than 0, x1 greater than 0. Then go up. This x2 greater than 0. That's why you see that shading this way. Okay? Shading this way. And here, shading this way. Okay? So, this is x1, okay? x2 greater than or equal to 0. And it is called the non-negativity constraint. Let's go on. So a non-feasible solution is a solution that does not satisfy all the constraints. Okay? If we choose a point here, as I said, if we choose this is not feasible. But if it falls within an area, this green four-sided figure, okay? If it's any solution we take here is a feasible solution. Then you have optimal solution. Optimal solution. An optimal solution is the solution that gives you the best result. Okay, if we are talking about a maximization problem, then an optimal solution is the best, is the point that will give you the maximum result. Okay, so in this case, you'll find that if you solve the equations of the two lines simultaneously, the result is going to give us this point, and this point is the optimal solution. This is the optimal solution. This point, okay, this is the maximum. Okay, the maximum result that you can get from the combination of what x1 and what x2. Okay, so this is the optimal solution. This is the point here for this. If it's a maximization problem, you can see this is the definition: the set of values for decision variables that optimizes the objective function while satisfying all constraints, and this represents the best possible outcome. Okay, so this is the optimal solution, and that's it. That's the point. If you solve these two equations simultaneously, the values of x1 and x2 you are going to get is the optimal values for x1 and x2. Now we'll talk about slack variable. A slack variable is what you add to, is what you use to convert the linear inequality to equality sign. Okay, you have this. For you to convert this, for example, this is 3x1 minus 2x2 is equal to 6. In order to convert it to an equality sign, you add a slack variable. Let's call it s1. You now say 3x1 minus 2x2, okay, plus s is equal to 6. This s is called a slack variable, okay. A surplus variable. If it's a greater than sign, you add a surplus variable. If it is less than sign, we add a slack variable. If it is greater than sign, okay, if the inequality is greater than sign, we use a surplus variable, okay. The artificial variable, if it's greater than sign or equal to, then we now use an artificial variable. By the time we'll be solving, you will get, by the time we start treating those cases where the constraints are using greater than equal to sign or equal to sign, then you see the advantage of surplus variable and artificial variable. Then the next thing we're going to do is to take an example here. Let's take this example. You can see the simplest method using a manufacturing problem. Okay, let's look at a manufacturing problem. A manufacturing company produces 3 products, A, B, C, using 3 machines, machine 1, machine 2, and machine 3. The company wants to maximize profit. Okay, there's a given data and so on. So what I would do, you can pause the video and study the question here, okay, to save time. Let me just go straight to the next step. Now, here are the steps to follow in solving a linear programming maximization problem using the Simplex method. Step 1, formulate the problem. Step 2, write the problem in standard form. Step 3, okay, draw the initial Simplex tableau. Step 4, carry out iteration. Okay, in carrying out an iteration, first of all, you locate the pivot column. After that, you locate the pivot row. Then you carry out elementary row operations. Then after that, you now check for optimality. Step 5, you check for optimality. The solution is optimal. Stop and calculate the maximum profit. Else, repeat steps 4 and 5 until optimality is achieved. Okay, so once you check for optimality, it's not optimal, you go back to step 4 and you continue. Okay, you iterate again, check for optimality. Once the solution is optimal, you calculate the maximum profit. So let's go to step 1 to formulate the problem. Step 1, formulate the problem. In order to be able to formulate the problem, you need to break it down like this. That's why I drew these tables. Okay, this table will help you in actually formulating the problem. We are told to maximize, okay, profit, that each product A has a profit of what? $3. Product B has a profit of $2 if produced. Product C has a profit of $4 if produced. Okay, then this is the machine time requirements. You have this for product A. Okay, for product A, for it to be produced, it's going to take 2 hours on machine 1, okay, 1 hour on machine 2, and 3 hours on machine 3. The same for the others. Then coming to machine availability, we know that machine 1 works for 60 hours per week, machine 2 works for 80 hours per week, and machine 3 works for 60 hours per week. So looking at these parameters, we can now formulate our linear programming problem like this. Now here is the formulation of the problem proper. Decision variable say let x1 equal to number of units of product A to be produced. Okay, let x2 be product B, and also x3 be product C to be produced. Okay, now this is the objective function. It's a maximization problem. Now we know that if we produce a unit of x1, which is product A, we make a profit of $3. If we produce a unit of x2, which is product B, we make a profit of $2. And also, if we produce a unit of x3, we make a profit of $4. So we're actually maximizing, okay, 3x1 plus 2x2 plus 4x3. This is the objective function. Subject to is the time it takes for each of the products to be produced on each of the machines. Okay, so on machine 1, remember, it takes 2 hours, okay, 2 hours of product A, 3 hours of product B, and 2 hours of product C. And when you add all of them together, it must not exceed the weekly allocation for the production hour for machine 1. Machine 1 can only work for 60 hours per week. Okay, machine 2 can work for 80 hours per week. Machine 3 can work for 60 hours per week. So this is the formulation of the problem. Then subject to, okay, also x1, x2, x3 greater than or equal to 0. This is what we call the non-negativity constraint. Okay, we must not have negative values. The minimum should be 0 for each of the units we are going to produce for products A, B, and C. Okay, so this is how to formulate the problem. The next thing is to write out our problem in standard form. Let's try this problem in standard form. The first thing, you look at this, you have the constraints, you are going to add what we call slab variables to them, because they are in the form of less than or equal to sign. Okay, for greater than or equal to sign, we'll treat that in another video. First, we'll add S1, slab variable. Second constraint, we add S2. The third constraint, we add S3. So we come here, we now say maximize the objective function. Okay, we have it as 3 x1 plus 2 x2 plus 4 x3. Then all the slab variables will be here. They're with 0 coefficients. So you now say plus 0 s1 plus 0 s2 plus 0 s3. Okay? Subject to the first constraint, 2 x1 plus 3 x2 plus 2 x3, okay, plus then s1 is added to this, so we add a 1, okay, as a coefficient and 0 for the others. So here we have plus 1 s1 plus 0 s2 plus 0 s3, okay, equal to 60. Okay, go to the next one. 1 x1, that is x1 plus 2 x2 plus 3 x3 plus, for this the constraint is s2, okay, s2, so there will be 0 s1 plus 1 s2 plus 0 s3 equal to 80. Okay, the next one, you have this 3x1 plus 3x2 plus 2x3 plus this x3. So it's only s3 that will have 1. The other two will be 0. So we have 0 s1 plus 0 s2, okay, plus 1 s3 is equal to 60. Then we have also that x1, x2, x3, s1, s2, s3, all greater than or equal to 0. With this, we have represented our LP problem in standard form. The next thing is to draw the initial simplex tableau. Step 3 here, draw the initial simplex tableau. We're going to draw the tableau and also fill in the entries. Now this is the table, okay, there's a table. Okay? So initial simplex tableau, for this you have here three slab variables here, 1, 2, 3. So for this setting, okay, it's going to give us 7 rows and 9 columns. 7 rows and 9 columns. You have 1, 2, 3, 4, 5, 6, 7. That's 7 rows. You have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is what the table you should draw. Okay, the table 7 rows and 9 columns. This first row here should be the heading. Okay, this should be the heading. This should be the heading. We now come here, okay, that's after the heading on top, okay, this point here is going to be the basis. Basis will enter there. After the basis, then you have the CJ row. CJ row will be there, okay. Then after that, the number of your slab variables, 1, 2, 3. So you have 1, 2, 3, okay. Then after counting the 3, 1, 2, 3, then here will be directly under this, you have ZJ row. Should be ZJ. The last row will be the CJ minus ZJ row. So you fill it there. That's CJ minus ZJ. Okay? Minus ZJ row. So this is how to fill it up. Okay? The first will be the heading. Okay? The space for the heading. After that, you come to your left hand side, you count 1, 2. You're going to start writing from here. Okay? You have 1, 2. Here is basis. After basis, the next one is CJ. Then under the CJ, after CJ, you can 1, 2, 3, which is the number of slab variables. There are 3. Okay, we have S1, S2, S3. You are going to start the table with the slab variables coming into the basis first. So you have 1, 2, 3. Then you now have ZJ. After ZJ below it, you now have CJ minus ZJ. Okay. Then the next thing is to start filling the heading. Okay. First of all, you fill the heading. I told you this place is the heading. So here we have X1, X2, X3. Okay. After that, you have the slab variables. You have the slab variables. You have S1, you have S2, you have S3. Okay. After that, here you have the right hand side. That's it. Then after that, you now start entering the values. For the basis, here will be S1, there will be S2, there will be S3. Okay. The slab variables will enter the basis first. Then after that, you start filling in the values. Okay. So X1, under X1, what's the coefficient in the CJ row? This is CJ row. X1, this is our CJ row. Okay. This is our CJ row. This is CJ row. So X1, we have a 3. X2, we have 2. X3, you have 4. S1, you have 0, 0, 0. Okay, you don't touch here, leave them. After that, you now come in here. Okay, come in here. CJ, the CJ column there, the CJ column here. What's the value of S1 in the CJ column? S1 CJ column is 0. Put it there. Okay. S2 in the CJ column is 0. Put it there. S3 CJ column is 0, 2. That's it. After that, you now come here. Here is the first constraint, the second constraint, and this is the third constraint. So under the first constraint, what's the coefficient of X1 in the first constraint? Come here. That is what? 2. Here, X2, 3. Okay. Then S3, 2. Okay. S1, 1. S2, 0. S3, 0. Okay. Then at the right hand side, 60. Okay. Go to the next constraint with the second. Second here, 1. X1. Coefficient of S2 here, 2. Okay. Coefficient of S3 here, 3. Okay. S1 here. Okay. Because you know, this is now S2. So it's going to be half coefficient of 1 under S2. Here will be 0. Here is 0. Okay. Likewise here, S3. Okay. S3. You just come here, put 1 there, 0, 0. Okay. Then you now come here, X3. Coefficient of X1 there is 3. Okay. X2 there, 3. X3, 2. Okay. Then under X2, 2, the constant term there, 80. Constant term here, 60. That's it. Okay. So enter, you can see how we are entering all the values. Go step by step. You won't make mistakes. Okay. You won't make mistake. Or any slight mistake can lead to error in your calculation. After that, you have the ZJ row here. Under the ZJ row is 0 everywhere. Because to get the ZJ row, it means 0 times 2 plus 0 times 1 plus 0 times 3. So here will be 0. 0 times 3 plus 0 times 2 plus 0 times 3 will be 0. So the same thing here will be 0 throughout. Okay. Then you now come to the CJ minus ZJ row. Okay. CJ is 3. 3 minus 0 is 3. Okay. 2 minus 0 is 2. 4 minus 0 is 4. 0 minus 0 is 0. 0 minus 0 is 0. 0 minus 0. So here it's like this, 0 throughout. But here you don't touch here. That's it. At the initial simplex tableau, okay, the values of our decision variables are 0. X1 is 0. X2 is 0. X3 is 0 at this point. Okay. X1 is equal to 0. Okay. X2 is equal to 0. And X3 is equal to 0 at this point. S1, okay, the slab variable here has, that's as a resource, it has a value of 60. S1 is equal to 60. S2 is equal to 80. And S3 is equal to 60. Okay. And so any variable that is not in the basis has a value of 0. Okay. This is the initial interpretation of this table. And with this, we have drawn the initial simplex tableau. The next thing we want to do, step 4, is to carry out iteration. Okay. The first thing is to locate the pivot column. That's we want to look for the column, okay, the variable that will come into the basis between x1 and x3. Okay, you can see that we have s1, s2, s3 in the basis already. So to do that, you look at the cj minus zj row and look for the most positive value here. And in this case, we have it as 4. x3 should come to the basis. It is the most positive or the greatest value in the cj minus zj row. So this is coming into the basis. This coming to the basis. This coming to the basis. Okay. And so this is known as the pivot column. After getting the pivot column, you now look for the pivot row. Okay. Then you look at the rows, each of the rows, you divide the right hand side, okay, by each of the volume of the elements in the pivot column. Okay, ignoring the values that are zeros and minus. Okay, you not divide any entry that is 0 will be ignored. Any entry that is minus, that is negative, will be ignored. So you divide the right hand side, okay, by each of the elements in the pivot column, and you take the least value to be your pivot row. So here you can write here that on my right, I can call this place ratio. Ratio. We divide the ratio here. So here, you now start dividing 60 over 2 is equal to what? It's 30. Okay, the next one, 80 over 3 is what? That's you have 2 there. Okay, actually when you are solving this problem, don't use decimal points. Make sure you are always leaving them in fractions. Okay, it's easier for you to calculate using fractions. So we have just leave it. That's what this is, 2 remaining 2. Okay, that is 2 here. Okay, 3 into this is 2 into 20 is 6. Okay, remaining what? 3 times 6, 18. 2 over 3. Okay, and the last one here is this. Okay, this is zj. We are not using this. We're not touching this last one. It's 1, 2, 3, because we want the variable that will enter the basis between x1 and x3 to replace, and as it's entering, this slab variable is leaving the basis at the same location. So the next one is what? 60 over what? Over 2. So you have 60 over 2. That will be what? 30. So among the 3 values here, which is the least? You take that value to be the pivot row. You take the least value here to be the pivot row. And that is this, isn't it? This. So this is our pivot row. This is our pivot row. Okay? This is our pivot row. Then, the intersection of the pivot row and the pivot column is the pivot element. So these are pivot elements. That's our pivot element, okay, which is 3. So from here, we're going to iterate, okay, and go to the next step. You can see it. Locate the pivot column. We have done that. Locate the pivot row. We have done that. The pivot row. Then carry out elementary row operations. After you must have identified the pivot element, which is the intersection of the pivot column and the pivot row. Okay, pivot row. You now come here and draw another simplex tableau. Okay, you can see that the heading is still there. Okay, you have here basis, Cj, 1, 2, 3, Zj, Cj minus Zj. Now you start filling them up. Let's start from here. In the Cj row, what is the coefficient of x1? You can see it's still there. Got it here at the top here. So you just copy it out again. Here is 3. Okay. Here is 2. Here is 4. Okay. 0, 0, 0. You don't touch anything here. Now if you watch, I've drawn a green line here to guide you. You're not going to carry out your computations to the left of this green line. Everything will be inside here. Okay. You just fill these ones up, but all your computations are going to take place within this green line here. Okay. Then this one will, as if we are summing it up. The Zj will be summing them up and so on. So let's go. We have filled this. We have filled this. The next is to come to the basis. We said that here S3 is coming in, okay, and S2 is leaving the basis. So here you have S1, write it there. S1. X3 is coming in, so here will be X3. Okay. Yes, S3. A basis comes in at the time. S3. That's it. Then after that, you now fill here. Fill here. This is the Cj column. What's the value of the coefficient of S1 in the Cj column? Okay, let's go back. Here we have S1, X3, and S3. So if we go back to our standard form, you can see that here S1 is 0, coefficient is 0. S2, okay, coefficient is 0. Then X3, the coefficient is 4. So we have 0, okay, 4, 0. Okay, for S2, it's 0. So we come down and fill them in. And so here we have the coefficient of S1 in the Cj row is 0. Okay, X3 in the Cj row is 4. Okay, while S3 is 0. Good. Can see we are filling it, coming out gradually. Can see that. So the next thing is to now come here to the new pivot element. You ask yourself, this point is going to be 1 because X3 at the point of intersection of a column and a row, okay, that's if it's in the basis, it should be 1. So here is 1. It's 1. Okay, here it's going to be 1. Then you ask yourself, what will you do to 3 to get 1? So divide 3 by 3. So we have 3 over 3 is equal to 1. Therefore, you divide each element on this row by 3. So we come here. The first one is 1 over 3. 1 over 3. Okay. The next one is 2 over 3. Okay. The next one is 0 over 3. That's 0. This is 1 over 3. The next one is 0 over 3, which is 0. Okay. Well, the next one is what? 80 over 3. 80 over 3. Now, when you're solving, make sure you leave your values in fraction form. Don't divide and start having decimal points. It makes it more difficult for you. So, as you are simplifying, as you are iterating, make sure you leave your values in fraction form. Now, we have gotten this. I've gotten this row. The next thing is that when you have a unit matrix like this, we are going to have a unit matrix wherever you have a variable that's in the basis. On here is going to have a unit matrix. Okay, so S1 is in the basis. So there we are going to have a unit matrix with the point of intersection of the column and the row being 1. So here will be 1. Okay, this X3, we are going to have a unit matrix with 1, the point of intersection. This S3, therefore here is going to be 1. Even without calculating, that's going to be your answer. Going to be 1. Okay, so we have 1, 1, 1. And everywhere to be 0, 0 here. Here will be 0, here will be 0, here will be 0. At the point of intersection, that's where you have 1 only. Then it will be 0 elsewhere. That's the language you use in mathematics. 0 elsewhere. So let's come here. We want to start filling them now. We now come to, you want to fill this 1 here. This is the next one here. You want to fill here. Okay. Then you go to, this is the pivot row. Okay. Pivot row. You multiply the pivot row by a given factor. Okay, subtract it from the new row and get 0. So this point is going to be 0. Point is going to be 0. So for here to be 0, you ask yourself, what do you use to multiply this element 1 here, okay, and subtract it from this point to get 0? It is 2. If we say multiply this by 2, because this is 2 already, we are looking for 0. So if you say 2 minus 2 times 1, that will give us 0. Okay? If the value here were to be negative, maybe we had minus 2 here, then you multiply this by 2 and add it to the value here to give us 0 as well. Do you understand? So the sign of this point determines this sign as well, this sign. If it is positive, then here will be minus. If this is minus, then there will be plus, because we want to achieve 0 value here. So when I come here, here should be 0. Okay? Because 2 minus 2 times 1 is 0. So our factor here, I call it x. X is equal to 2. As we are going to be dealing with this row, our x is equal to 2. So whatever we have is going to be the value here minus the 2, which is the factor, times the value here. That's it. So let's come here. 2 minus 2 times 1 will give us 0. Come here. 1 minus 2 times 0 will give us what? This 0 give us 1. This is correct. Go to the next one. Okay, the next one, which is this point. Okay, that will be 0 minus 2 times what's the corresponding position, which is this. Okay, minus 2 times this, 1 over 3. Okay, that will be minus 2 over 3. So here is going to give us minus 2 over 3. Okay, go to the next one, this position, okay, which corresponds with what? This position. So you have 0, okay, 0 minus 2 times 0. Okay, 0 minus, this is our factor, x is 2. So 0 minus 2 times 0 will give us what? 0 minus 2 times 0 is what? Is 0. So here will be 0. Okay, you can see this giving us 1, 0, 0 already. And now come here, here will now become, there will be 60 minus 2 times 80 over 3. 60 minus 2 times 80 over 3. That will give us 60 minus 160 over 3. LCM will be 3. 3 times 60 will be 180. Okay, minus 2 times 160. Okay, that will give us 20 over 3. Okay, over 3. So here is going to be 20 over 3. That's it. That's it. When you come to this side as well, let me clean here. And let's come here. This is the value here. Corresponding here, that's 3. So 3 minus 2 into 2 over 3. That will give us 3 minus 4 over 3. Here is 3. Okay. Here will be 9 minus 4, which is 5 over 3. So here will be 5 over 3. Okay. Here will be 2 minus 2 times that. 2 minus 2 into 1 over 3. Okay, that will give us this 2 over 3. 2 minus 2 over 3. LCM is 3 there. Okay, 3. Here you have 6 minus 2. Okay, which is 4 over 3. So here will be 4. There's going to be 4 over 3. We are finished with that row. Okay, let's look at the next row. Now let's look at this next row now. Let's look at the next row. You go to the corresponding position there. Okay, this is the point. This is 2. Okay, this is 2. You ask yourself, what do you use to multiply this value and subtract it from this new value that's coming? So you have 2 minus is where you use 2. Okay, 2 times 1. Okay, 2 minus 2 times 1. That will give us 0. Okay, that means for us to get 0 here, it means 2 minus 2 times 1. Okay, that will be 0. So put this down the 0 there. Then you use that x now. Is x in this case equal to 2. You use the 2 to multiply all the values on this row and subtract them from the corresponding value on the old tableau. Okay, so we come here now. Okay, you say this will now be 0, 0. Okay, minus 2 times 0. Okay, that will give us 0. Okay, come here, 0 minus 2 times 1 over 3. 0 minus 2 times 1 over 3. Okay, minus 2 into 1 over 3. That will be 0. That's minus 2 over 3. Okay, that minus 2 over 3. That will be minus 2 over 3. Okay, you can see this already 1. But to confirm, if you calculate, you get the same answer. You come here, that is this point 1. This will be 1, okay, 1 minus 2 times 0 to give us this. Okay, 2 times 0 is 0. Then 1 minus 0 will give us 1. And the next one is here, okay, 60 minus 2 times 80 over 3. 60 minus 2 times 80 over 3. Okay, that will give us this. We have done it before. Okay, that will be 3. This will be 180 minus, okay, the answer is 20 over 3. We know there's 1. That will be 2 times 80 will be 160. Okay, so that will be 20 over 3. So here is going to be 20 over 3. Okay, 20 over 3. Okay, coming here, the same 2 as the multiplying factor. You go here, that's this point here. Okay, that's this position here. Okay, so that will be 3 minus 2 times 2 over 3. Okay, 3 minus 2 times 2 over 3. Okay, by using 2 to multiply the value here, subtracting it from the corresponding value there. So 3 minus 2 times 2 over 3. Okay, which is this? Where is it? 3 minus times, so that will be 3 minus 4 over 3. So we have gotten before. That's 3 minus 4 over 3. Then you have 3 here. That will be 9 minus 4, 5 over 3. So here will be 5 over 3. Okay, then the next one here, where's the corresponding position? That is 3 here. Okay, that's 3 here. So this is going to be 3 minus 2 times 1 over 3. Okay, 3 minus 2 times this value here, 1 over 3. That will be 3 minus 2 times 1 over 3. Okay, LCM is 3. 9 minus 2. Okay, that will be 7 over 3. So yeah, we're going to have 7 over 3. Okay, we've gotten this. I've gotten the row. So the next thing is to compute the ZJ value here and the rest of them. Let me clean here so that I can make it clearer for us. The next thing is to calculate the ZJ values. ZJ is 0 times 4 over 3, okay, plus 4 times 1 over 3, plus 0 times 7 over 3, okay. So this one, this will be 0, this will be 0. We are left with what? 4 over 3. Okay, you come here, this value here will be 0, value here will be 0. We are left with 4 times 2 over 3, that will be 8 over 3. Okay, we come here, this will be 0, okay, 0 times this is 0, okay, this is 1, so we are left with 4 here, okay, you come here, this will be 0, 0 times 1 is 0, 0 times, so 4 times 0 is 0, so everything here is 0, you come here again, 0 times this is 0. Okay, 0 times this is 0. We are left with 4 times 1 over 3, which is 4 over 3. We come here. This is 0. This is 0 as well. 4 times 0. So here will be 0. They're going to be 0. Okay? Be 0. Okay? Because this is 0 times 0, that's 0, plus 4 times 0, which is 0, plus 0 times 1. So the next one is 0 times this will go, cancel. 0 times this will go as well. So I'm left with 4 times 80 over 3. Okay? What would that give you? 4 times 8 is 32, so that will be 3. Okay? 20 over 3. Yes, that's the value. Then after that, we go to the Cj minus Zj row. That means these are Cj. 3 minus 4 over 3. What's going to give us there? We have 3 minus 4 over 3. LCM is 3. 9 minus 4. Okay, that will be 5 over 3. So it will be 5 over 3. Okay, the next one is what? Is 2 minus 8 over 3. 2 minus 8 over 3. 3 here. That's 6. Okay, minus 8. That will give us minus 2 over 3. Minus 2 over 3. The next one, we come here. 4 Cj minus Zj row. 4 minus 4, that's 0. 0 minus 0, that's 0. We come here. 0 minus 4 over 3, that will be minus 4 over 3. Okay? And the next one, we have 0 minus 0 is 0. Okay, that's it. So, that's it. And the next step is to determine whether the tableau is optimal or not. Okay? You check the Cj minus Zj row. Okay? Okay? Yes. If you have any positive value, okay, then it means the tableau is not optimal. Okay? If you have any positive value, in this case, we have a positive value. And if it is more than 1, if you have more than 1 positive values, okay, then you take the greatest positive value. You take the greatest positive value. But in this case, if x1 goes into the basis, okay, the profit will be increased by this value, by this 5 over 3. Okay, this is the extent, okay, the margin, okay, to which the objective function will increase, which means objective function will be maximized, okay, by any value here coming into the basis. Okay, if x2 comes into the basis, it will be reduced. If x3 comes in, you can see 0, nothing will happen. So we see that this is the maximum Cj minus Zj row. So it comes into the basis. Therefore, this is our pivot column. This is our pivot column. That's our pivot column. Let's leave it like that. Then after that, you now come to the right-hand side. This right-hand side. You divide each right-hand side by the elements in the pivot column. Okay? And you take the least ratio. Okay? This side now. Here, this is the ratio. The ratio here. I'm going to take the ratio. So for this case, this first one is going to be 20. And meanwhile, as you divide the right-hand side by each element in the pivot column, you ignore values that are 0 or negative. Any value that is 0, you don't divide it, it's ignored. Okay? But in this case, we don't have any 0 value here, nor negative value. So let's divide 20 over 3. Okay? Divide 4 over 3. Okay? 4 over 3. That will be equal to 20 over 3 times 3 over 4. This will go, then you have, this will be 5. Okay? That is 5. So the ratio here is 5. That's 5. Okay? The next one, 80 over 3. This next one, 80 over 3. Dividing 1 over 3. That will be 80 over 3 times 3 over 1. That's 80. So the next one is 80. Okay. That's for this row. Okay. That'll be equal to 80. Let me write it here. Then the next one will be 20 over 3. Dividing the corresponding value there, which is 7 over 3. Okay. This is 7 over 3. 7 over 3. That will be 20 over 3 times 3 over 7. Cancel. That will be 20 over 7. Okay. 20 over 7. 20 over 7. Okay. Now, you look at these three values. Which of them is the least? Okay. 20 over 7, about 2 point something, isn't it? 3 times 7 is 21. So that's 2 point something. So this is the least, meaning the last one here is going to be our pivot row. Okay. This last one here is our pivot row. This is our pivot row, which means S3 is leaving the basis, okay, while X1 is coming into the basis. Okay, so let's go to the next iteration and continue from there. From here, we know that the pivot element, okay, pivot element, let's write it out. The intersection of the pivot row, okay, and the pivot element, the intersection of the pivot row and the pivot column gives us the pivot elements, which is this. That's our pivot element, which is 7 over 3. So let's go to the next iteration. Now that we have drawn the second tableau, we need to fill in the entries and start iterating again. So the first thing is to fill in the headings. Okay, that's X1, X1, X2, X3, then S1, S2, S3. That will be our right hand side. Okay, and I'll come here to the basis. Okay, now this is S1, then here is X3. Okay, and we said X1 is coming in while S3 is leaving. So here we fill in X1. Okay, that's it. That's all. Filled it up to that point. The next thing is to see that once you enter the decision variable that is coming into the basis, once you fill it here, you go and fill in the pivot element here. So you ask yourself, this place is going to be 1. Since you have X1 here, the point, that's the column, okay, the intersection of the column, and that variable must be 1. So here should be 1. Okay. Likewise, this X3, okay, this X3, when you have X3, here will be 1 as well. We have S1, it will be 1. Okay. And after that, you ask yourself, first of all, complete the one for the pivot row, the new pivot row. That's the one you complete first, because that's what you're going to use to fill others. Okay, you're going to use this new pivot row to compute the values for all other rows. So here is going to be 1. Then you ask yourself, what do you use in multiplying 7 over 3 to get 1? Okay, what will you multiply 7 over 3 with to get 1? So you now say that's going to be what? The inverse of this. The inverse of 7 over 3. That will be 3 over 7. Because you remember, 7 over 3 times 3 over 7 is equal to 1. You see that? See that? If the value there were to be an integer, let's say 5, okay, then you know that for you to get 1 here, okay, you multiply by the inverse of 5, which is what? 1 over 5. Okay? Which means you are going to divide everybody on that row by 5. That's the meaning. In this case, it is a fraction. So, what do you use to multiply the value here to get 1? Okay? It is what? 3 over 7. We therefore multiply every value on that row by what? By 3 over 7. Meanwhile, notice this place is a green line. You must not compute beyond this line to your left. You start from this X1 to your right. Okay? So you multiply each term by what? By 3 over 7. So come here, 5 over 3 by 3 over 7 over 3 times 3 over 7, that will be 5 over 7. So here it's going to be 5 over 7, okay? Now the next one, here is 0 times 3 over 7 will give us 0. Here is 0 times 3 over 7 will give us 0. This is minus 2 over 3, minus 2 over 3 times 3 over 7. That will be what? Minus 2 over 7. Minus 2 over 7. The next one is 1. 1 times 3 over 7. That will be 3 over 7. Okay. And the next one, 20 over 3 times 3 over 7. 20 over 3 times 3 over 7. That will be 20 over 7. Okay. That will be 20 over 7. So that will be 20 over 7. Then, after filling this, you can go back to the C0 here. C0 here. Okay. You can just go up and bring it down. 3, 2, 4. 2, 4, 0, 0, 0. 0, 0, 0. That's it. Okay. You can see that. Fill the CJ row. Fill in the new pivot row. Also, we now fill in the CJ column here. Now ask yourself, S1, remember, all the slab variables, S1, S2, S3, they have a value of 0. Okay? The column on the CJ row there, they have the value of 0. So S1 here, on the CJ row there, okay, on the CJ row, it has a value of 0. The coefficient of X3, okay, on the CJ row, you still remember, the value of X3 on the CJ row, under the standard form, X3, the CJ row, X3, okay, you can see the coefficient is 4, okay, and X1 coefficient is 3. So come down, there's it. And so, under X3, coefficient is 4. Under X1, the coefficient is 3. Good. So we've gotten this, we've gotten this. The next thing is to start filling others. Now, you know I said, when you have it here, to save you time, you don't need to calculate for this point, you don't need to calculate for this point, you don't need to calculate here, you don't need to calculate here. So you can just fill them up. Where the value here, the variable here is in the basis, the point of intersection of the column and the row will be 1 and 0 elsewhere. So since you have here 0, you have here 0, okay? You have here 0, you have here 0, okay? This S1 is in the basis, so 0, 0. X3 is in the basis, so 0, 0. Okay, see? So you succeeded in filling all these ones at a go, okay, without calculating. And the next thing is to now come here. Want to fill in here, want to fill in here. You ask yourself, how did you get 0 here? Go back to the pivot column here, okay? You go up, want to fill here now. To get this point here, 0, you go up to the corresponding cell, which is 1 over 3, okay? So you tell yourself that the value here, we are going to call it X. It is X now, okay? Let me clean here. You can see here, the value here, you go to the corresponding value here on the old tableau, which is 1 over 3. So you now say X is equal to 1 over 3. This is our multiplication factor. We're going to use this 1 over 3, okay, to multiply each term on this row, starting from here, from 1, okay, to your right, and subtract that value from the corresponding value in the old tableau here, okay. That's how you can get 0 here. For example, for you to get 0 here, okay, is 1 over 3, that's the old value here, is 1 over 3, that's the value there, minus this value here, which is our X, minus 1 over 3, times the new pivot row entry, which is 1. Put in 1 there. So this will give you 0, okay? So to come here, you come here, you say, what is, so we're going to use X to get all of that values. So we call it 2 over 3, this point now, to get this value here, okay, will be what? The old value 2 over 3 minus our X here, 1 over 3, okay, into the new value here, 5 over 7. Please remember that if x is negative, that is, if x is minus 1 over 3, the middle sign is going to be plus. So we're going to have 2 over 3 plus 1 over 3 into 5 over 7. Okay, so that will give us LCM. That's 21, 3 dash 7, 14, minus this 21 into this 1, okay, minus 5. Okay, so that will give us 14 minus 5, that's 9 over 21. Okay, you have 3 here, 3 here, 7. So here is going to be 3 over 7. Okay, and you look at the next one, which is here. You don't need to calculate for these ones. Okay, you don't need to calculate for these ones. You come here, because you are sure that since S1 is here and S1 is here, the point of intersection is going to be 1. Okay, and 0 elsewhere. So every other place must be 0. And you come here now, come to this point. What is the old value there? It's what? It's 1 over 3. So you have 1 over 3 minus our x. What's our x? Our x, okay, this row, our x is what? 1 over 3 into, okay, the new value here, okay, this one, minus 2 over 7, okay, minus 2 over 7. So you solve from here, that will be 1 over 3 minus times 1 will give you plus, okay, 2 over 21. LCM is 21, okay, 3 dash 7, that will be 7, plus 2, okay, is 2. That will be 9 over 21, which is like this one, which is this as well. 9 over 20, that will be 3 over 7. So here will be 3 over 7. That's going to be 3 over 7. Now go to the next one. This is the next one, okay? Now the value there is what? Is 0. That's 0 minus of x here, 1 over 3, into the new pivot row, 3 over 7. Okay, that will be minus 1 over 7. Okay, 1 over 7. That will be minus 1 over 7. Okay, you go to the next one. What's the corresponding value here? Is what? Is 80 over 3. That will be 80 over 3 minus our x. Our x is this guy, 1 over 3. Okay, into our new pivot row value, 20 over 7. Okay, so that will be what? That will be 80 over 3 minus, we cannot cancel here, so just leave it like that, as 20 over 21. LCM, we have 21, okay, 3 there, 7. 7 times 8 is what? 56. At the 0, minus 20. That will give us what? 540, okay, over 21, okay. If we try 3, for example, we say 3 here will be 7, 3 here is 1, okay, into 24 is 8. Okay, good. That's 180. So that's 180 over 7. Cannot go. So let's leave it like that. 180 over 7. Okay. The next thing is to fill this point, this row. I'm going to fill this row up. You now ask yourself, this is 0 here. What's the factor at this? What's the value at this point here? It's 4 over 3. Therefore, okay, our multiplication factor x is equal to what? 4 over 3. Okay, it's 4 over 3. You now come here, at this point, you go there to the old value, is what? 5 over 3 minus a multiplication factor, 4 over 3 into the new value. What's our new value here? Now pivot row, 5 over 7. Okay, so work this out. This will give us 21, okay? Then 3 there is 7, so that's 35. Minus, okay, this is 1, okay? This 21 to 21 give us 1, then that's 20. That will give us, you have a 5, that's 15. 15 over 21. 3 there, 5, 3 here, 7. That will be 5 over 7. So here it's going to be 5 over 7. Okay, you can see we have done this already. You come to the next one here. Okay, what is the odd value there? Minus 2 over 3. I say minus 2 over 3. Okay, minus bracket open. Okay, our x 4 over 3 into, okay, the new value there. Talking about here now. What's the new value here? That's on the pivot row. Minus 2 over 7. Okay, so minus 2 over 3. Minus will give us plus. Okay, nothing can cancel here. That will be 8 over 21. Okay, so the LCM is what? 21. 3 there, 7. That minus 14. Plus 21 there is 1 times that, that's 8. So this will give us minus 6 over 21. 3 can go. We have 2. Okay, 3 here, 7. That's minus 2 over 7. We now come here. Okay, we are here now. Okay, that is minus 2 over 7. Okay, that's our value there. The next one here, look at the corresponding position, which is 0, minus our x 4 over 3 into the new pivot row value is what? 5 over 7. Okay, so that will give us minus, this will be 20, okay, 20 over 21, okay, so that will be minus 20, because look at it, this is 0, 0, minus our factor, 4 over 3, 0 minus 4 over 3, into the old value there. The old value there is what? 5 over 7, okay, yes, 5 over 7, and so we have minus 20 over 21, okay, so can anything go? No, that'll be minus 20 over 21. We go to the last one, the last entry there is this 20 over 3. That'll be 20 over 3 minus 4 over 3 into the new pivot row is 20 over 7. Okay, so that will be, can anything cancel here? No, that will be LCM, that will be 21, that's this 2. 3 there, 7 times this, 140, minus, this one will be 1, 4 times 20, that will be 80, okay? What will this one give us? 140 minus 80, okay? That will be 60, okay? That will be 60. 60 over 21. 3 here, 20, 3 here, 7. Okay, that's 20 over 7. So here it's going to give us 20 over 7. Good. Now we have finished filling in all these values. The next thing is to look at the ZJ row and the CJ minus ZJ row. To get the ZJ row, okay, we have 0 times 0 plus 4 times 0 plus 3 times 1. This will give us 3. Okay, here this is 0. Okay, 0 times 5 over 7 plus 4 times 3 over 7, okay, 4 times 3 over 7 will be 12 over 7, plus, okay, 3 times 5 over 7, that will be 15 over 7. This is 7, 12, that's 2 plus this, 7, 2, okay, that will be 27 over 7. Here will be 27 over 7, okay, that's it. Next one is 0 times 0 plus 4 times, this will give us 4. This is 0 plus 0 plus 0. This will give us 0. Okay. Then this one is, at this point here, 0 times this is 0. 4 times this will be 12 over 7. Plus 3 times minus 2 over 7. Okay. We have 3 into minus 2 over 7. That will be 12 over 7 minus 6 over 7. Okay, 7, 12 minus 6 is 6. Okay, that will be 6 over 7. So it will be 6 over 7. Then here, the next one, 0 times this is 0. 4 times minus 4 over 7. Okay, that will be minus 4 over 7. Okay, this is 4 times minus 1 over 7. Then plus 3 times 5 over 7. 5 over 7. Okay, that will give us 7. Okay, this will be minus 4 plus 15. That will give us 11 over 7. Okay, it will be 11 over 7. So yes, 11 over 7. But the next one is going to be 0 times this, that will vanish. 4 times 180 over 7 plus 3 times 20 over 7. Okay, 4 times 180 over 7 plus 3 times 20 over 7. 3 into 20 over 7. Okay, we're working on this. So 4 times 180. Okay, that will be, let's just write it there. 4 into 180. Okay, LCM, two of them are 7, 7. Okay, then here 3 times 20 over 7 is 60 plus 60. Okay, over 7. So let's look at this. 180 times 4. This is 0. This is 32. Carry 3. Okay, 4 times this is 1 plus that. That's 720 plus 60. Okay, that will give us 0, 8. Okay, 7. That will be 780 over 7. Can it go? No. 7 here 1. It cannot go. That's 780 over 7. Over 7. Okay, that's it. So after that, we now need to subtract Cj minus Z0. 3 minus 3, okay, is 0. This is 27. 2 minus 27 over 7. Like this. That's 7. That's 14 minus 27. That will give us minus 13. Okay, minus 13 over 7. Minus 13 over 7. The next one, 4 minus 4, okay, is 0. The next one, 0 minus 0 is 0. Okay, then here we have 0 minus 6 over 7. That will be minus 6 over 7. And the next one, 0 minus 11 over 7. That will be minus 11 over 7. Okay, so here you don't do anything to this point. So if we check the Cj minus Z0, none of them is above 0. They are all negative and zeros. Therefore, our tableau is optimal. Okay, our tableau is optimal. From here, our x3 is equal to 180 over 7, and our x1 is equal to 20 over 7. Since we have our optimal solution here, we can now write out the solution. Since we have our optimal solution, product A, x1, which is product A, okay, is equal to what? Is equal to 20 over 7 units. Okay, which is equal to 20 divided 7. That gives us 2.857 equal to 2.857 units. Okay, yes. Then as x2, which is product B, is equal to what? x2 is equal to 0 because it's not in the basis. Then x3, which is product C, product C is equal to 180 over 7, which is equal to 180 divided 7. That is 25.714 units. Okay. then the profit, maximum profit, is equal to, okay, maximum profit, okay, maximum profit is equal to the value of ZJ here, 780 over 7, which is equal to, delete it, cancel, 780, okay, divide 7, that will be 111.429. Let's leave it like that. $111.429. Okay. Okay. Now let's write out the real answer. All these values that have been given to us by way of the formula, but in reality we can't produce half units. Okay, so we're going to round this off to what? To 2 units. It's not up to a whole unit here. So it will be 2 units. While this one will be what? Will be 25 units. Then multiplying the 2, we'll get our profit. Okay, our maximum profit. So let's go back. Let's go out. We can now conveniently say that product A, okay, is equal to what? 2 units. Okay, product B I should produce how many units? 0, okay. While product C, I should produce 25 units. Okay, and the maximum profit, max profit, is equal to the unit price for A, okay, which is 3, times 2 units, okay, plus the unit price for C, which is 4, okay, times number of units, 25. And that will give us 6 plus this 100, that's 106. That is going to be, the maximum profit is going to be 100, is going to be 4 times 25, 100 plus 6, which is $106. That is the answer we are expecting. So this is the true solution to our problem. Thank you for watching. Now, if you have enjoyed this video, I want you to share the video, give the video to your friends, your colleagues. Okay, if you're a lecturer and want to learn how to teach like this by solving on the screen and do a lot of things as a lecturer or as a teacher, then visit my website, teachwithcomputer.com. You get a book there which is called The Digital Teacher. With the book, you actually be versed in manipulating the computer to do a lot of things. Record your lectures, okay, write on the screen, okay, write a book, okay, a lot of things are inside that book. The name of the book again is The Digital Teacher.